Welcome to this lesson of our study of linear algebra. So this lesson takes you through when you should know that your system or maybe your kind of equation that you are trying to solve has no solution, one solution and then many solution. All right. So let's first pick the first problem and then try to do it. Solve for x and y in the equation. 7x minus 5y equals 3. So I have 7x minus 5y equals 3. How do I find x and y in this kind of equation? I want to solve for both x and y. So what I can do is I can try to write both x and y in terms of the other. So 7x is equal to 3 plus 5y, and then here x will be equal to 3 plus 5y all over 7, and this can be written as 3 over 7 plus 5 over 7y, right? So I know that x is equal to 3 over 7 plus 5 over 7y. Now that is basically the solution to this. That's the only thing we can do. We can't actually do anything again. So what happens if I have this? What this is telling us is that if I have any y and I put x to be 3 over 7 plus 5 over 7y, then this equation here, if I sum them, I'll get 3. Indeed, this is true. If I put 7 times x, right? So I'm going to put x is what? 3 over 7 plus 5 over y, 5 over 7y, sorry. What should I get minus 5y? I mean, I'm trying to solve this equation. I have 7 times x, and x is this, right? So if I do that, if I multiply 7 through, I'm going to have 3 plus 5y minus 5y, and these two will cancel, and I'm going to get 3, right? And indeed, it's true that if x is equal to this, then 7x minus 5y will always give you 3. That's what this means. This means that if I choose any value, any real value that you can choose for y, s can take this form. So if I say that let y to be equal to maybe 1, then x will be equal to 3 over 7 plus 5 times y, which is 1 over 7, and that's going to give me 8 over 7. And indeed, if I put 7 into 8 over 7 minus 5 into, remember we said that y is 1 in terms of this case or this scenario, I'm going to have, this will take that 8 minus 5, and that is 3. Again, I challenge you to choose y equals maybe 2, and that should also work as well. So it means y can take many forms, and whichever form you choose for y, you get a different value for x. So this is a clear example of an equation or maybe a system that has infinitely many solutions. I don't know if this makes sense, but this is what it means, that you can choose most values for y, and then that is y is a free variable. You can choose anything for y, and then whatever you choose for y affects x, and it gives you different set of solutions, right? So in the more appropriate way to do this, most people will say, okay, y is a free variable, so it means that y is equal to some t, where t maybe you can say is real. You can define it, and then x will be equal to 3 over 7 plus 5 over 7t, right? And so whatever value you choose for t in the real values, you're going to get two different solutions for the system. Now the next system is find x1 and x2, x3 in this equation. Alright, so I'm going to do the same thing. X1 minus 5x2 plus 4x3, this should give me 7. So what this whole thing means is that I can try to write x1 in terms of the other one. So 7 plus 5x2 minus 4x3, and in that case I have x1 to be 7 over 3 plus 5 over 3 x2, minus 4 over 3 x3. And what this means is that if I put x1 to be this and come and put it in this equation, sum everything, I'm going to get 7. And that should be the case. That should work. Because if I put x1 to be that, look, this x1 is 7 over 3 plus 5 over 3 x2 minus 4 over 3 x3, then minus, I'm going to add these guys, 5x2 plus 4x3. What will I get if I multiply, if I distribute 3 throughout? I'm going to get 7 here plus 5x2 minus 4x3 and minus 5x2 plus 4x3, and this can take this away, this can also take this away, and I'm going to be left with 7. And that makes sense, right? It really makes sense here. So what this is telling us is that we can't do anything to x2 and x3 because we don't know them, right? But we can actually write x1 in terms of x2 and x3. So this is again a system that has infinitely many solutions, but here we have x2 and x3 to be free variables. We can choose any value at all for x1 and x2 and x3, and then we can write x1 in terms of that. So the appropriate solution to this is that x3 should be equal to some t which belongs to maybe the real numbers, and maybe x2 should be equal to another variable. Maybe you can choose s, which also belongs to the real numbers. So it means that x1 will always be equal to 7 over 3 plus 5 over 3 x2, where x2 is s, sorry, and then I have minus 4 over 3 x3, and x3 here is what? T. So note the difference. This is 5 and this one is s. All right, so that is the solution to this system. Right, now let's go to the next one. Now the next problem is which actually takes a system of solving linear equations for which values of the constant k that the following system of equations have no solution. So I'm going to explain that with this example. When do we say that the system has no solution? And there's only one solution and then infinitely many solutions. In our previous video, what we did was an example of a system that has exactly one solution, and in that case I had only one values for x1, x2 and x3. Each one had one values, right? That was x and xyz actually, yeah, not x1 and x2. All right, anyways, let's come back to here, which has x and y to be solved for. Now the appropriate way to solve this is to use augmented matrix, or maybe augmented matrix, where I'm going to put the coefficient in front of the variables in that, and add the values at the latter part. I normally want to separate it with different colors so that you know that those are the equality part. Okay, so what I'm going to do, I said in a previous video that to solve this you have to use something called elementary row operation. And what you're going to do is make sure that you stand on the first row, look for the first leading value. Always make sure that there's a value there. If there is no value, switch that row with a row that has a value in there. What I mean is, assuming that we have something like 0, 1, 2, maybe then another value here, which is the equality part, and I have maybe 1, 3, 4, maybe another value which is also the equality part. Now I want to solve this. What I have to do is first switch these two. So I'm going to just switch row 1 and row 2. Okay, and what is going to happen? I'm going to write row 2 in on top. Maybe here was A and here was B. Then I'll have to write A here. I have to switch everything. I'm going to write the other one like this, and then B. All right, and that is what I mean. So you have to always make sure that your first row has a leading value. Some people want to always make sure that this leading value is so special, that is 1. Sometimes you might not get it to be 1, and if there is any row that has 1 as a leading value, you can actually switch them. All right, let's come back to here. What I'm going to do is I'm going to make sure that the value beneath that is 0. And to compare 1 and 2, 1 can be 1/2 of 2, or maybe 2 can be equal to 2 times 1, right? So it depends on what you want to do. Now I know either I use 1/2 or maybe 2 to do my operation. So what I'm going to do is I'm going to transform this into a new row 2, what I'm going to get, and that is going to be given by 2 row 1 minus row 2, and that is going to make sure that this guy is 0. If I multiply 1 by 2, I'm going to get 2, and then subtract from I'll subtract 2 from it, I'm going to get 0. So this is going to give me a different matrix, which is 1, -1, 3, and then down here I'm going to get 0. Then 2 times -1 is going to be negative 2, then minus negative 2, and that's going to be to negative 2 minus 2, right? And that's going to be negative 2 plus 2, which is 0, and then 2 times 3, which is 6, minus this k, so I'm going to have 6 minus k here. Notice that this part is what we have. All these that I have here are the equality parts. So whatever you have here represent the variables, and what I have at the end is the equality part. Now let's look at this. When can I say that this system has no equation? The first thing is I'm going to answer that problem. When does it have no equation? What values of k will make this equation have no solution? First, let's look at what it means. I'm going to put x and y here. What this whole thing means is that if I come to the second row, I'm going to have 0x plus 0y is equal to 6 minus k. And the question is it possible that you multiply 0 to x and 0 to y, you're going to get some value? Is it possible? So that's what you're supposed to think about. And then the other row is 1, that is x minus y should be equal to 3. Now let's answer the first problem. The first part is, when does it have no solution? It has no solution if k is not equal to 6. Now why am I saying if k is not equal to 6? I'm going to get a value here. If k is maybe 7, I'm going to have 6 minus 7, which is negative 1. It means that 0x plus 0y is negative 1, and it doesn't make sense. That means you have no solution. That means we have no solution in terms of something like that. Okay. Actually, when the system gives no solution, it always comes from the last row. Mostly comes from the last row. If you have two variable row, or maybe element to be 0, 0, and then the last part of the equality row, column is actually a value other than 0, then this equation or this system has no solution, or it's inconsistent system. Let me put it that way. So if k is not 0, not 6, then its system has no solution, because there's no way that you're going to have 0 times s plus 0 times y to be a number other than 0, right? So now let's go to the b part, which says exactly one solution. Now, are you sure we can actually get exactly one solution? That is one thing we are thinking about right now. I'm going to say, let's answer the C part first before we come to the B part. All right. So with the C part, infinitely many solution, and that's going to help us answer the B part. So what that means is, at what point are we going to get infinitely many solution? We can get a solution if k is equal to 0. Equal to 6. If k is equal to 6, what it means is that the last row is giving us something like 0x plus 0y equals 6 minus 6. And k is 6, so I'm going to have 0. So it means the last row will give me 0, which makes sense, right? So 0 times x plus 0 times y is actually 0. That makes sense. Now the next other one is going to be x minus y is equal to 3. And that means x is equal to 3 plus y. And like we did for the first two problems, y is a free variable. So I'm going to choose any value at all for y. And that is going to give me infinitely many solutions. So y can be 1. And I'm going to get x to be equal to 4. Y can be 2. And I'm going to get x to be equal to 5. And all these are going to give me, correct solutions or infinitely many solutions. So the B part is there any value of k that when I put here, I'm going to get exactly one solution? I'm going to say no. And if you, when I say no, there isn't. That's what I mean. There is no such k. You don't have any k that can give you this kind of exactly one solution. The only possible is either you have infinitely many solution or no solution. All right, thank you, and don't forget to subscribe to my channel if you have not subscribed. We'll look at more involving problems in our next class. All right, see you.